Here's something you do every single day without thinking about it. You turn a corner and your two front wheels, or your two driven wheels, spin at completely different speeds. The outer one travels further than the inner one. If they were locked together, your tyres would scrub, hop and screech every time you left the car park. So how does the car let them spin at different speeds while still driving both of them? The answer is a little cluster of gears most people have never seen. Let me take you all the way through it. So step back and watch the whole machine now. Power comes in along the drive shaft. The pinion turns the crown wheel through 90 degrees and gears it down for torque. The crown wheel spins the carrier. Inside, the spider gears either sit locked for straight line driving or roll to let your wheels disagree round a bend, adding to one exactly what they take from the other. And a limited slip pack steps in when grip runs out. All of that happening silently under your floor, every single corner for the entire life of the car, usually never needing a thought. That's the differential, one of the quietest bits of genius you own. The answer is the limited slip differential. The goal isn't to lock the wheels together, that'll bring back the cornering scrub, it's to resist too much difference in speed. The common design stacks clutch packs between the side gears and the carrier. Under normal cornering, small speed differences slip freely. But when one wheel tries to spin far faster than the other, those clutches bite and transfer torque back across to the wheel that still has grip. Some designs use a clever gear called the torsion, which uses worm gears that jam under load. Either way, you keep the smooth corner and kill the one wheel spin. That's the whole trade-off engineers spent a century refining. That'd bring back the cornering scrub bit. That same mechanism that averages speed also averages torque, and torque always follows the path of least resistance. Put one wheel on ice and one on dry tarmac, and here's the ugly truth. The icy wheel spins uselessly at double speed, while the gripping wheel gets almost nothing. Because the diff can only ever send as much torque to the good wheel as the slipping wheel can hold, and the slipping wheel holds almost none. So you sit there, one wheel spinning wildly, going nowhere, with a perfectly good grippy tyre doing nothing. It's maddening. This is called an open differential, and it's what most ordinary cars have. So how do you fix it without losing the cornering trick? Driving in a straight line, both wheels want to spin at the same speed, so the spider gears don't rotate on their own pin at all. They just get carried around by the cage, acting like a solid locked block, feeding equal speed to both side gears. Here's the beautiful bit. Go round a corner, and the outer wheel wants to go faster. That extra speed forces the spider gears to start spinning on their pin. As they roll, they speed one side gear up by exactly the amount they slow the other side gear down. The average stays locked to the carrier. One wheel gains, the other loses. Perfectly balanced, automatically. No sensors, no thinking, just geometry doing arithmetic. But that same cleverness hides a nasty flaw. That chassis don't rotate on their pin. As they roll, this bolted to that big crown wheel is a cage, the carrier. It spins as one lump with the crown wheel. And here's the magic. Inside that cage sit small gears mounted on a pin, free to spin on their own axis. These are the spider gears or pinion gears. Facing them, pointing out to each wheel, are two side gears. The spider gears mesh with both side gears at once, so the carrier carries the spiders around in a circle, and the spiders in turn drive the two side gears, which are splined to your half shafts, straight out to the wheels. This little gear cluster is the entire heart of it. Now watch what it does when you drive straight versus round a bend. The engine's power arrives spinning along the length of the car, but your wheels spin across it, a 90-degree change of direction. That's handled by two gears, a small one on the end of the drive shaft called the pinion, and a big one it drives called the crown wheel or ring gear. Their teeth are cut at an angle, bevel gears, so they mesh cleanly at right angles. And because the crown wheel is much bigger, this pairing also gears the whole thing down. The typical final drive ratio is around 3:5 or 4:1, so the pinion spins nearly 4 times for every single turn of the crown wheel, multiplying torque on the way. But the crown wheel isn't bolted to the wheels. Look closer. So the whole job of the differential is this. Take one input, the spinning drive shaft, and split it into two outputs that can rotate independently while still delivering engine torque to both. That's genuinely a hard thing to ask of gears, and when I first understood how they pulled it off, it honestly stopped me in my tracks. The trick isn't electronic, there's no clever computer here. It's pure mechanical geometry, invented properly back in the 1820s and 30s. A cluster of gears that averages out speed automatically. But before the split happens, the power coming in has to make a right angle turn, and that's where the first clever part lives. Start with the problem, because it's sneakier than it looks. When your car goes round a bend, the outside wheel is following a bigger circle than the inside wheel. On a tight turn, the outer wheel might travel a meter or two further in the same amount of time. That means it has to spin faster. Now here's the catch. Your engine sends power down a single spinning shaft.